So I'm Andrew, and about a year ago, I took a class on Computational Theory, which is an interesting place to find a passion of yours, but that's what happened. So in that class, I learned about a problem called P versus NP, okay? Now, and it actually has serious implications in the real world in finding cures for diseases, in creating perfect economies, and things like that. So first, let's ask some questions. What is the problem? What does it ask? It really says, can we solve every solvable problem quickly, okay? But being computer scientists, we don't like ambiguous terms like quickly and not quickly. So we decided to categorize them. We said, okay, a problem is in P, or it's a quick problem, if, as the size of the input to the problem increases, the time that the problem takes to be solved doesn't grow that much, right? That's the specifics of it. And if, as the size of the input to the problem increases, the time that the problem takes to be solved increases dramatically, then it's going to take a long time to solve, and we call it NP. Okay? So as these classes relate to each other differently, but I want to draw your attention to this circle right here. Okay? So then NP complete in it. Now, a problem is NP complete if every other NP problem can be transformed into it quickly. For example, Sudoku. So Sudoku is it's a puzzle we're all fairly familiar with, right? It's generally played on a 9x9 board, but it can be enlarged to a 25 by 25, shrunk down, right? So we can change the size of it. Now, it turns out that every NP problem can be changed into Sudoku quickly, right? Which means if we can change every problem to Sudoku quickly and then solve Sudoku quickly, we suddenly solved all of those other problems quickly, right? And so that actually leads to some of the keys of all of the problems of this world, for example. Okay? So my method for solving this is solving Sudoku quickly. So here's how it works. We have this 2x2 Sudoku board, it's really simple, right? So what we do is we assign every column a number and every row a number by taking all the numbers and smashing them together, okay? Then we smash all those numbers together, and then all those numbers together, and we end up with a huge number of 12 digits, okay? But if you look at it, we only use 3 different digits there, 0, 1, and 2, okay? So we can treat that as a number in base 3, which is just a different way of counting. And then we can convert it to base 10, okay? And we end up with 220,191 as a number that uniquely represents this table, okay? That's the important part. So, if we think about this, we can take a table, okay? So if you can change it. Then we can convert it to a number, and if we perform arithmetic operations on that, like addition, subtraction, multiplication, and division, then we can try to achieve a desired number, right? And then if we convert that back into a table, then we could theoretically find the solution to the original table, right? Quickly, okay? Because arithmetic operations are incredibly fast, okay? Which means that we could have a solution to all these NP problems. But what's the point? So, as I mentioned earlier, there are actually some serious implications in the real world, for example, cryptography, okay? We all have secret information that's super important, like passwords and bank account information, for example. And so we encrypt that information. And the reason that encryption works is that if someone wanted to decrypt that information, it would take them long past the heat death of the universe to do so. And so it's not really practical, okay? But if the Sudoku solution works, if P equals NP, then it turns out that we could break all of that. We could decrypt all of the information and have to totally redesign the internet, okay? That would be significant. A more optimistic application is in biology. Because it turns out that our bodies have proteins in them, okay? And these proteins fold differently. And depending on how they fold, they perform different functions, okay? Now, if people could figure out how to correctly fold those proteins, we could program them to go and isolate cancer cells and get rid of them, or cure Alzheimer's, for example, okay? So that would be cool. And if P equals NP, if the Sudoku solution works, we could do that. We could fold those proteins. We could cure every disease known to man, okay? That would be cool. And then also the Clay Mathematics Institute is offering $1 million for the first person solution. So, okay. So that's my idea for solving this problem. Now, it's clearly not fully fleshed out, right? There's still problems, but I hope it can be a stepping stone to eventually reaching that problem so we can create a better world and improve everything that we know.